Page 387 to 388. Page 387 to 388. All right, first of all, the definition of a proportion is an equation that shows that two ratios are equal. Okay, right now it doesn't seem that they're equal, but if I reduce 6/10 to simplest form, they are in fact equal on both sides. So a proportion shows that two ratios are equal to each other, okay, in an equation. Now, there are two ways to solve proportions. The first way that we're going to look at is by using equivalent ratios. I look at the side of the ratio, okay, top or bottom, that is already filled in. So here it's going to be 30 and 60. And I need to figure out what the missing link is, okay? What the missing link is. If I'm going from smaller to larger, what number do I multiply 30 by to get to 60? 30 times what equals 60? 2. Okay? This is going to be like my missing link. So 30 times 2 equals 60. But I can also go the other way. Larger to smaller, 60 divided by 2 is what? 60 divided by 2 is, guess what? 30. Okay? So my missing link is 2, and it can go both ways. So whatever my missing link is on the bottom, guess what? It's my missing link on the top. So 150 times 2 is going to be what?
300.
C equals 300. And if I substituted it back into the proportion, is it true that 300 divided by 2 would be 150? Yes, it is. Okay, so it can go both ways as well. All right, so using equivalent ratios. If it's the same on the bottom, okay, whatever number it is on the bottom, it's going to be the same number on the top because the ratios have to be equivalent in measure. Now let's look at B. Okay, again, I'm using the side of the ratio that is already completed. 7 and 21. Well, what's going to be my missing link? How do I get from 7 to 21?
3.
I multiply by 3. That's my missing link. I can multiply 7 times 3 to get 21, or I can divide 21 by 3 to get to 7. It can go both ways. So again, whatever I do to one side, I can do to the other, and 8 times 3 is what? 24. And that's going to be my answer. Is it true that 24 divided by 3 is 8? Yes, it is. So it can go both ways. Now, here's why I'm showing you how it works both ways. What if your variable is in the first ratio? And now, I'm looking at the relationship between 2 and 8. Okay, how do you get from 2 to 8? 2 times what equals 8? 2 times 4. Okay, in the same token, 8 divided by 4 equals 2. So now here I know that my missing link is 4, and 16 divided by 4, I'm kind of going backwards, is what? 4, and x equals 4. All right, so this is how I use equivalent ratios to solve a proportion. Most of the time, using equivalent ratios, as long as it's going to be a whole number, is the easiest way to go. But what if you had a set of numbers like these in example 2? 10 times what is going to equal 25? Well, that's not a whole number. 10 times 2 is 20. 10 times 3 is 30. So in this case, using equivalent ratios, what about 14 and 49? That's not going to be an even number. What about 27 to 12? That's not going to be an even number. So sometimes using equivalent ratios is not the most practical way to solve a proportion. Okay? So we can use another method. We can use algebra. This is what you learned in Chapter 7. This is nothing new. We are simply solving for the variable. All right? So 6/10 equals x over 25. How do I get x by itself? I have to multiply by the reciprocal. Whatever I do to one side, I do the same thing to the other. Cross-reduce if possible. A lot of people are forgetting about this. Okay? And you have 30 over 2. Okay? Equals x. And then x equals what? 15. Okay? All right, now I'm going to give you a minute, pause the recording, and I want you to do B the exact same way. All right, how do I solve for M? How do I solve for M? You've had a minute to do this. Jared? Very good. Very good. I need to multiply by the reciprocal. Okay, now I want to ask myself, can I cross-reduce 49 and 14? Yes, I can. By 7. Okay, and that would give me 28 over 2. Now, if you didn't catch that, then you should have gotten, what, like 126 or something? 126 over 14? All right, but you should still end up with the correct answer. Equals 14. Okay, so x equals 14. All right, hopefully you got that. But what if the variable is in the first ratio? Like on C. I have C over 27 equals 9 over 12. Does it change the way that I solve? No, it doesn't. What do I need to multiply by to get C by itself? 27. Whatever side that variable's on, I have to get everything else to the other side. Multiply both sides by 27. That cancels it out, and I'm left with C equals, and I have 27 over here. Can I cross-reduce? Yes or no? Yes, I can, by 3. 4 and 9, and I end up with C equals, it doesn't work out. C equals 81 over 4. At this point, I would want to change it to a decimal. So somebody put this in your calculator and tell me what you get. All right, and as a decimal, it's going to be C equals 20.25. Okay, but on your quiz and your test, they'll work out a lot nicer than that. All right, last but not least, okay, setting up a proportion given a word problem. You can bank on me giving you one of these on a quiz or a test, okay? So here, this is going to call on that higher level reasoning, okay? You have to be able to pick apart a word problem and set up your proportion. So here's the question. It says, yesterday you bought 8 bagels for $4, and today you only want 5 bagels. How much is it going to cost you? There are several ways that you can set up this proportion. The first way is you can just set up the bagels yesterday and how much they cost yesterday to your bagels today and how much they cost today. Okay? But that's not the only way you can set up this proportion. You could set it up, the cost of your bagels yesterday to the bagels today, and the cost today to the bagels today. What characteristics do these two proportions share? They are comparing bagels to bagels in our numerators and cost to cost in the denominators. And on the same token, on the second example, again, we're comparing cost to cost and bagels to bagels. As long as you're comparing the same unit on both sides of the proportion, you do, in fact, create a proportion. Okay? So that's how you set up a proportion. Now let's look at example 3. All right, read along with me on page 389, the Empire State Building example. It says, at maximum speed, the elevators in the Empire State Building can pass 80 floors in 45 seconds. How many floors can the elevators pass in 9 seconds? So let me go ahead and write down the comparison that I know for sure. I know that it can pass 80 floors in 45 seconds. What I don't know is how many floors in 9 seconds. Again, I'm comparing floors to floors and time to time on the bottom, okay? So I have set up this proportion correctly. 80 over 45 equals x over 9. Now, I told you you can use either method, and you can. You can use either method to solve. One way is probably going to be easier than the other. So what do you think? Should we use equivalent ratios, or should we use algebra? Here's how you answer that question. Look at what you already know. Is there a direct and clear relationship between 45 and 9? Yeah. Is there a way you can get from 45 to 9? Yes. How? You can divide by 5. Since that's a very clean answer, there's no decimals involved, that's going to be the easiest way to do this. Now, I could multiply by the reciprocal, both sides, and then reduce and all of that, but why do that when I can simply say that 45 divided by 5 is 9, So 80 divided by 5 is what? What is it? 80 divided by 5? Not multiplied.
16.
X equals 16 floors. Now your book used algebra to solve. Why? Equivalent ratios is easier. When it's a clean answer like that, okay, when there's a clear relationship between the parts of the ratio that you already know, that's the way to go, okay? And that's all you need to know for 8.4.